Hello children, today we will start our discussion from page number 12. Heading is Periodic Trends in Properties, Electronegativity. So the first definition of electronegativity, the tendency of an atom to attract electrons to itself when combined in a compound. Okay children, and one more line is given here. Electronegativity indicates the net result of the tendency of elements to attract the bond forming electrons. Okay children, so when an atom attracts electrons towards itself in the combined state, then this is known as electronegativity of that atom. Okay children, और बॉन्डेड कंडीशन में कोई एटम कितने फोर्स के साथ इलेक्ट्रॉन अट्रैक्ट कर रहा है. ओके अगर वो ज़्यादा फोर्स से इलेक्ट्रॉन अट्रैक्ट करेगा तो उसकी इलेक्ट्रोनेगेटिविटी विल बी हायर in comparison to other one atom which is having a comparatively less force of attraction for the electron. Okay children, for example in the case of HCl and HF. Okay, so in these two compounds, Cl and fluorine being a electronegative atom are attracting these shared pair of electron towards itself. Okay, लेकिन जो फ्लोरीन एटम है उसका जो फोर्स ऑफ अट्रैक्शन है फॉर दीज शेयर्ड पेयर ऑफ इलेक्ट्रॉन इज कंपैरेटिवली मोर देन दिस क्लोरीन हेयर. ओके, इट मीन्स फ्लोरीन इज मोर इलेक्ट्रोनेगेटिव इन नेचर देन द क्लोरीन. ओके चिल्ड्रन, तो बॉन्डेड कंडीशन में जब कोई एटम बॉन्ड फॉर्मेशन में यूज इलेक्ट्रॉन्स को अपनी ओर अट्रैक्ट करता है तो दिस अट्रैक्शन ऑफ द इलेक्ट्रॉन्स इज नोन एज इलेक्ट्रोनेगेटिविटी ऑफ दैट एटम. ओके चिल्ड्रन, देन हाउ इलेक्ट्रोनेगेटिविटी प्ले इट्स रोल for the formation of these two type of compounds. These two type of compounds means in the ionic compound and in covalent compounds. Okay, so in the case of ionic compound, the participating atoms are having comparatively more difference in their electronegativity than the covalent molecule forming atoms. Okay children, for example, here in the case of NaCl, sodium chloride, because Cl is having a very high electronegativity than the sodium atom, that is why Cl will take away one electron of the sodium with it. Okay, and due to that ionic bond will form here. So ionic bond is formed between combining atoms if atoms differ widely in electronegativity. Okay, और अगर रिलेटेड एटम्स की इलेक्ट्रोनेगेटिविटी का डिफरेंस जो है वो बहुत कम है या अबाउट निग्लिजिबल है तो उन एटम्स के बीच में कोवेलेंट बॉन्ड फॉर्म होगा. जैसे कि क्लोरीन के केस में, क्लोरीन मॉलिक्यूल में क्या होता है, ये जो दोनों पार्टिसिपेटिंग Cl एटम्स हैं उनकी इलेक्ट्रोनेगेटिविटी सेम होगी. तो इन इलेक्ट्रोनेगेटिविटी सेम होने की वजह से इनकी इलेक्ट्रोनेगेटिविटी का डिफरेंस जो है ना वो ज़ीरो होगा और इस ज़ीरो डिफरेंस की वजह से जो इनमें बॉन्ड फॉर्म होगा वो शेयरिंग ऑफ इलेक्ट्रॉन से होगा, यानी कि कोवेलेंट बॉन्ड बनेगा. ओके, तो कोवेलेंट बॉन्ड फॉर्मेशन के लिए क्या है, कोवेलेंट बॉन्ड बिटवीन कंबाइनिंग एटम्स if atoms have nearly similar electronegativities. Okay children, the next is factors which affect the electronegativity. So the factors are, first is atomic size. Atomic size increases, electronegativity decreases. Okay children, so atomic size के inversely proportional है electronegativity. Atomic size बढ़ता जाएगा, related एटम्स का इलेक्ट्रोनेगेटिविटी डिक्रीज होता जाएगा. Reasons affecting the electronegativity are the same and in the same order as electron affinity. Okay, तो क्या हो रहा है यहाँ पर, इलेक्ट्रोनेगेटिविटी डिक्रीज कर रही है एटॉमिक साइज इंक्रीज होने के साथ. ओके, एटॉमिक साइज इंक्रीज होने के साथ इलेक्ट्रोनेगेटिविटी डिक्रीज कर रही है. क्यों डिक्रीज कर रही है? क्योंकि एटॉमिक साइज इंक्रीज कर रहा है तो इसका मतलब क्या है कि नंबर ऑफ शेल्स इंक्रीज कर रहे हैं, है ना. नंबर ऑफ शेल्स इंक्रीज कर रहे हैं, तो फर्स्ट तो रीजन ये हो सकता है बाय द ड्यू टू द इंक्रीज इन नंबर ऑफ शेल्स, जिससे क्या होगा, न्यूक्लियस का जो फोर्स ऑफ अट्रैक्शन है वो इलेक्ट्रॉन्स के लिए कम होता जाएगा और इसीलिए इलेक्ट्रोनेगेटिविटी क्या होगी, डिक्रीज करती जाएगी. दूसरा रीज़न क्या है कि लेस न्यूक्लियर चार्ज. तो अगर न्यूक्लियर चार्ज लेस है तो भी इलेक्ट्रोनेगेटिविटी क्या हो जाएगी, डिक्रीज कर जाएगी. ओके चिल्ड्रन, सो एटॉमिक साइज बढ़ने के साथ इलेक्ट्रोनेगेटिविटी क्या होगी, डिक्रीज करेगी. एंड सेकेंड इज न्यूक्लियर चार्ज, जो भी मैंने आपको यहाँ बताया. न्यूक्लियर चार्ज अगर इंक्रीज करता है तो इलेक्ट्रोनेगेटिविटी इंक्रीज करेगी और अगर न्यूक्लियर चार्ज डिक्रीज करेगा तो इलेक्ट्रोनेगेटिविटी डिक्रीज करेगी. ओके चिल्ड्रन, then next is trends in electronegativity across a period from left to right. ओके, तो इसका ट्रेंड जो है इलेक्ट्रोनेगेटिविटी का वो सेम ट्रेंड है एज वी हैव सीन ऑलरेडी इन द केस ऑफ इलेक्ट्रॉन अफिनिटी एंड आयोनाइजेशन पोटेंशियल. सो फ्रॉम लेफ्ट टू राइट electronegativity increases. Okay, from left to right electronegativity increases in the period. Okay, up to chlorine, you can see here in third period, from sodium to chlorine it is increasing. Okay, atomic what is the reason of this increase? Atomic radii which is decreases, so electronegativity increases. And highest for halogens, non-metallic character so increases from left to right in a period. So electronegativity increase करता है means non-metallic character भी increase करते हैं, और you can say कि non-metallic character increase करता है इसलिए electronegativity भी क्या होती है, increase करती है. The second factor nuclear charge increase करता है from left to right in period and इसीलिए क्या होता है, electronegativity भी क्या होती है, increase होती है. Then elements with high electronegativity are usually non-metallic. Okay, तो हाई इलेक्ट्रोनेगेटिविटी के जो एलिमेंट्स हैं वो राइट हैंड साइड पीरियोडिक टेबल में रखे हुए हैं और इसीलिए ये जो है ना, ये क्या है, नॉन मेटलिक इन नेचर है. सो नॉन मेटल्स आर इलेक्ट्रोनेगेटिव वाइल मेटल्स आर इलेक्ट्रोपॉजिटिव एलिमेंट्स. फ्लोरीन इज द मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट, ओके चिल्ड्रन, in the periodic table, while cesium the least. The noble gases have complete octet and hence do not attract electrons to itself. So due to the stable electronic configuration in noble gases, helium, neon, argon, they are not showing any attraction for the electrons, extra electrons. Okay, so next heading, electronegativity. It is here shown the trend of the electronegativity in period left to right increases. Then fourth point, trends in electronegativity down a group. So in group up to down it decreases. Okay, so you can see here in this group, halogen group, from up to down electronegativity is decreasing from fluorine to iodine. Then what is the reasons? Atomic radii increases from up to down in the group, that is why electronegativity decreases. Okay, the nuclear charge increases, electronegativity should be increased, but increase in atomic radii dominates over increase in nuclear charge. So overall क्या है कि electronegativity up to down group में क्या हो रही है, decrease हो रही है. Okay children, so this is electronegativity and its trend in periodic table. Moving to next page, periodic tends in properties metallic or non-metallic character. Okay, so the term metallic and non-metallic character, heading is metallic character, electropositive, non-metallic character, electronegative. So in terms of electron losing property, an atom is said to be a metal if it loses one or more electrons when supplied with energy. Okay, so metals are the elements which are having ability to lose their electrons. Okay, and this number can be one or more than one electron. Here it is shown with the help of an equation. This is metal. After loss of one electron, it gets converted in the form of M plus ion. Okay, children. Then non-metallic character. In terms of electron gaining property, an atom is said to be a non-metal if it gain one or more electrons when supplied with energy. So non-metallic नेचर जो है एलिमेंट्स का, उसमें क्या होता है कि जो रिलेटेड एलिमेंट होता है वो इलेक्ट्रॉन को गेन करता है. ओके, इलेक्ट्रॉन गेन करता है और ये इलेक्ट्रॉन जो है ना एक या एक से ज़्यादा हो सकते हैं. तो इलेक्ट्रॉन गेन जो एलिमेंट्स शो करते हैं उन्हें हम नॉन मेटेलिक एलिमेंट्स कहते हैं. ओके, with the help of this equation, this N is a non-metal which is after gain one electron is converted in the form of negative ion with one negative charge. Okay, then factors influencing metallic and non-metallic character. Factors. First is atomic radii increases, so metallic character also increases, whereas non-metallic character decreases. Okay, children. Ionization potential increases, metallic character decreases, and non-metallic character increases. Okay, so atomic radius when increases, it is increases, then metallic character increases and non-metallic character decreases. Ionization potential increases, then metallic character decreases and non-metallic character increases. Okay, children. Then metallic atoms present on the left side of the periodic table have large atomic radii and low ionization potential value and tend to lose electrons. Okay, so metallic atoms are the atoms which are having these all properties. Okay, first they are placed towards left hand side in the periodic table, having large atomic radii, low ionization potential value, and they are having ability to lose electrons. So the elements which are showing these all characters collectively will be known as metals. And non-metallic atoms present on the right side of the periodic table have a small atomic radius and high ionization potential value and tend to gain electrons. Okay, children. So non-metals are carrying just opposite property of the metals, having a small atomic radii, high ionization potential, and having ability to gain electrons. Metals are good reducing agents, while non-metals are good oxidizing agent. Okay, so this reducing nature and oxidizing nature is based on their electron losing and electron gain ability. If any element is having ability to gain electron, it means that will be an oxidizing agent, and if it is having ability to lose electron, then that element will be reducing agent. Greater the tendency to lose electron, the greater is the reactivity of the metal. So metals का जो reactivity है वो डिपेंड करता है उनकी इलेक्ट्रॉन लूज एबिलिटी पर. कितनी जल्दी वो इलेक्ट्रॉन लूज करते हैं ये उनकी रिएक्टिविटी कहलाता है. इसी तरह से जो नॉन मेटल्स होते हैं, द ग्रेटर द टेंडेंसी टू गेन इलेक्ट्रॉन्स, ग्रेटर इज द रिएक्टिविटी ऑफ नॉन मेटल्स. नॉन मेटल्स में जो रिएक्टिविटी होती है वो उनकी इलेक्ट्रॉन गेन एबिलिटी पर डिपेंड करती है. कोई नॉन मेटल कितनी जल्दी इलेक्ट्रॉन गेन करता है वो उतना ही ज़्यादा क्या होगा, रिएक्टिव होगा, या आप कह सकते हो कि वो उतना ही अनस्टेबल होगा. मोर रिएक्टिव मीन्स लेस स्टेबल. ओके चिल्ड्रन. Then next is change in character across a period left to right. So you can see here from left to right, uh, elements are showing a change in their character from metal to non-metal, and the last element of all the periods is a noble gas. So characters are changing from metal to non-metal. So metal, then metalloid, then non-metal. Okay, so from left to right in period, nature of elements or atoms are changing from metal to non-metal. Okay, in a period from left to right, atomic radii decreases. So due to the decrease in atomic radii, metallic character decreases but non-metallic character increases, and ionization potential increases, so metallic character decreases and non-metallic character increases. Okay children, this is the trend in period metallic to non-metallic character increases across a period. Then in the group from up to down in the group, non-metal to metal means up to down in the group, metallic character increases. Okay children, why? Because atomic radii increases up to down in the group, so metallic character increases whereas non-metallic character decreases, and ionization potential decreases due to increase in radii, so metallic character increases and non-metallic character decreases. Okay children, then elements at the bottom of a group are most metallic, have large atomic size, lowest ionization potential value, electrons are loosely held and will form ions from metal most readily and so are most reactive. Okay, so when we are moving up to down in the group, so what changes are taking place in the atoms of different elements? Atomic size increase हो रहा है, ionization potential value less हो रहा है, सो क्या होगा कि उनकी जो इलेक्ट्रॉन लूजिंग एबिलिटी है वो इंक्रीज करेगी, और इससे क्या होगा, उनका जो मेटेलिक कैरेक्टर है वो इंक्रीज करेगा और वो मोस्ट रिएक्टिव होंगे. तो जैसे जैसे हम बॉटम साइड पे जाएंगे, रिएक्टिविटी ऑफ द एलिमेंट्स इन द ग्रुप विल इंक्रीज ड्यू टू लॉस ऑफ इलेक्ट्रॉन फ्रॉम द atom or related element. Okay children, so trend which is given here, metallic character increases, non-metallic character decreases down a group. Okay children, then after this, next page, periodic properties, other physical and chemical properties. So in this page, some physical properties are given. Okay, so out of these physical properties, as you can see, the first, density, melting and boiling point. So across a period, density and melting point of elements increases gradually. Okay, so across the period it increases gradually, melting point and density, and then it decreases. Okay children, then down a group, density increases gradually and melting point and boiling point of elements decreases gradually. So density is increasing down the group, but melting point and boiling point is decreasing down the group. Chemical properties, periodicity and properties of compounds of elements. So these are the compounds: oxides, hydroxides, oxyacids and hydrides. So varies from across a period. Across a period, strongly basic to strongly acidic, oxides. Then hydroxides, strongly basic to amphoteric. Oxyacids, weak oxyacids to strong oxyacids. And hydrides are from basic to strongly acidic nature. Okay children, and down a group, oxides are changing from acidic to basic. Hydroxides are changing from less basic to more basic. Oxy acids are changing from strong oxy acids to weak oxy acids, and hydrides are changing from less acidic to more acidic nature. Okay children, this is the trend of the different compounds in the group. Then arrangement of stable and unstable elements in the periodic table. So light metals or light elements arranged in the periodic table having a n upon p neutron proton ratio around 1 are a stable element. Okay, so stable elements are those elements which are showing neutron and proton ratio equals to 1 are known as light element or stable elements, whereas heavy elements are those elements which are showing their neutron proton ratio 1.5 or more than it. Okay, so which are showing this ratio result 1.5 or more than it are unstable elements, also known as heavy metals like uranium. Okay children, so as you can see here with the help of examples, sodium, which is having 11 proton and 12 neutron. Okay, so its NP ratio will be 1.1, whereas uranium is having 144 neutron and 92 proton, so its neutron proton ratio is 1.5. so uranium is comparatively unstable than the sodium or potassium. So sodium and potassium are stable elements, whereas uranium is an unstable element. The next is values of atomic size, ionization potential, electron affinity and electronegativity. Okay children, so these all the properties we have discussed already. Atomic size, it will increase up to down in the group but decrease from left to right in the period. Ionization potential will increase left to right in the period but decrease up to down in the group. Electron affinity will increase left to right in period but decrease up to down in the group. Electronegativity again will increase left to right in the period and decrease up to down in the group. Okay, so these all trends you can summarize with the help of the values which are given here. Okay, these values are not asked to you. Okay, just general trend of these properties you just keep in your mind. Okay, and the questions will be based on their trend only, not on the basis of their values. Okay, so no need to learn these values, you just find out what trend is shown with the help of these values. This much you can just clarify. Okay children, so this is the last heading of this chapter. You just start doing the exercise of this chapter, and you have to do all the questions of the exercise with the pencil in book only. Okay, and some very important questions we will do in fair copy. Okay children, so accordingly you have to maintain your classwork copy. Okay, thank you.